Welcome learners. Today's topic is electrochemistry. Subtopic is electrolysis of aqueous solutions, a continuation of the previous lesson. Now in today's lesson we look at the factor number 2, which is concentration of electrolyte. Now concentration of electrolyte usually affects discharge of anions only. Then point number 2 you're supposed to note is that when I say concentrated solution, it means the amount of solute in solution is more than the amount of solvent. Therefore, example we give is electrolysis of concentrated sodium chloride using graphite electrodes. Now, in concentrated sodium chloride, the amount of sodium chloride in solution is more than the amount of water. Therefore, it means that the amount of sodium ions and chloride ions are more than the amount of hydrogen ions and hydroxide ions from the water. The anion, that is the chloride ions, which is in high concentration, will be discharged in preference to hydroxide ions. Now, the ions present in concentrated sodium chloride are sodium ions from the solutes. We have chloride ions from the solutes, then you have hydrogen ions and hydroxide ions. Now the ions that migrate to the anode are chloride ions and hydroxide ions. Now the ions that are prevent discharge at the anode are chloride ions, shown in the equation below. They say 2 chloride ions aqueous loses electrons to form chlorine gas plus 2 electrons. Now the reason for discharge of chloride ions is because chloride ions is in high concentration compared to hydroxide ions. Now the ions that migrate to the cathodes are sodium ions and hydrogen ions. Now the ions that are discharged at the cathodes is hydrogen ions, as shown in the equation below. Now because we have said in the anode we are losing 2 electrons, then it means at the cathode we are going to lose the same 2 electrons, and we said hydrogen ions gains 1 electron, so it means for me to gain 2 electrons I require 2 hydrogen ions. So the equation becomes 2 hydrogen ions aqueous plus 2 electrons gives you hydrogen gas. Now the reason for discharge of hydrogen ions is because hydrogen is below sodium ions into chemical series, and I said in the factor of concentration it only affects discharge of anions only. So hydrogen ions are therefore discharged because they have high tendency to gain electrons than sodium ions. Points to note about electrolysis of concentrated sodium chloride are pH. Now at the start of the experiment the pH was 7 because it was a solution, a salt solution. At the end of the experiment the pH increases. Reason is, look at the ions which are discharged at the electrodes. Among the ions for the discharge, we discharge chloride ions were discharged at the anode and hydrogen ions were discharged at the cathode. So the ions that remains is sodium ions and hydroxide ions. So therefore it means the sodium hydroxide solution formed is alkaline, or you can say due to high concentration of hydroxide ions. Now sometimes you may be told a mixture of gases may be formed at the anode. The reason is this: at the start of the experiment chloride ions are discharged because of high concentration to form chlorine gas. After some times, when the concentration of chloride ions and hydroxide ions are equal, hydroxide ions are discharged to produce oxygen gas. Now the diagram below shows electrolysis of concentrated sodium chloride using graphite electrodes. Now, in this diagram here, you're supposed to know that this longer line is positive. So this is a positive terminal battery and this is a negative terminal battery. Now the positive terminal battery is always connected to the anode. So this electrode here becomes the anode here. The negative terminal battery is always connected to the cathode. So this electrode becomes the cathode. Now we said earlier on that in electrolysis of concentrated sodium chloride, at the anode we produce chlorine gas. So here we have chlorine gas, and at the cathode we have hydrogen gas. So this is hydrogen gas. Now photo number 3 is nature of electrode used. Now we're going to look at an example here. That is, we're going to say, example is electrolysis of dilute copper sulfate using copper electrodes. Now what you're supposed to note in this example is that when the anode is made of a metal similar to ions in solution, in this case it is copper anode in copper sulfate solution, so the anode dissolves in the solution, none of the ions get discharged. None of the anions that migrate to the anode will be discharged. Now the ions present in dilute copper sulfate are copper ions, sulfate ions, hydrogen ions, hydroxide ions. Now ions that migrate to the anodes are sulfate ions and hydroxide ions. Now we said earlier on that because the anode is made of copper, then none of the ions get discharged. Instead, the copper anode dissolves into solution as shown. Copper solid will lose 2 electrons to form copper ions, aqueous, plus 2 electrons. The ions that migrate to the cathodes are hydrogen ions and copper ions. So we have copper ions and hydrogen ions. Now ion discharge at the cathodes are copper ions because copper ions are below hydrogen in the electrochemical series. So the equation for discharge of copper ions becomes, because we are losing 2 electrons at the anodes, so the same 2 electrons will be gained by copper ions at the cathodes. So you have copper ions aqueous plus 2 electrons gives you copper solid. So the reason why copper ions are discharged is because they have high tendency to gain electrons than hydrogen ions. Now points to note about this electrolysis of dilute copper sulfate using copper electrodes is the color of the electrolyte. Now at the start of the experiment, the color of electrolytes was blue in color. At the end of the experiment, the color is blue. So observation made, you say the blue color of solution is retained. Reason is this. Now when the copper ions are discharged at the cathode here, they are replaced at the anode. So the reason becomes copper ions discharged at the electrode are replaced at the anode. Now point number 2 is the mass of the anode decreases because the copper anode dissolves into solution as copper ions. Point number 3 is mass of the cathode increases because the copper ions are discharged by gaining electrons to form copper solids, which are deposited at the cathode. Point number 4, no gases are formed because at the anode the copper rod dissolves solution to form copper ions. None of the sulfate ions or hydroxide ions are discharged. At the cathodes, copper ions are discharged to form copper solid. Now in another example under the nature of electrode, we will say electrolysis of concentrated sodium chloride using mercury cathode. In the previous example, we said electrolysis of concentrated sodium chloride using graphite electrodes. The product we are getting was chlorine gas at the anode and hydrogen gas at the cathode. Now, when you are using mercury cathodes, sodium ions are preferring discharge to hydrogen ions, hence no gas is formed at the cathode. Learners, that's the end of the lesson. The next lesson we're going to look at quantitative treatment of electrolysis. Thank you. Subscribe and share. Wow. Very